Hi, my name is Tan, and I am one of the founders of StabiliTeeth, an affordable, stabilizing electric toothbrush geared towards improving dental hygiene in populations lacking fine motor control, such as Parkinson's, ALS, or stroke. Current-day solutions for people with Parkinson's disease or similar tremor-inducing conditions confine themselves strictly to rudimentary solutions regarding dental hygiene. They are often told to switch to an electric toothbrush or add attachments to their original toothbrush, such as a wider grip or weights. Complaints from this population arise when these suggestions do not significantly improve their abilities to accomplish this task, to brush their teeth. We propose combining all three of these suggestions, a wider grip, weight, and oscillating head in combination with the concept of a gimbal system, commonly used in camera stabilization and drones, to develop an ergonomic tremor-reducing electric toothbrush designed to react to tremors by producing compensating movements. Our first design focused solely as a proof of concept. It consisted of a double servo motor stabilizing mechanism paired to an accelerometer and microcontroller setup. Relative angles are picked up by the accelerometer, and deviations from a set baseline are processed by a microcontroller. Euler offset angle calculations tell the two servo motors to provide for longitudinal and lateral stability. Only stabilizing these two rotation angles allows for translational motion to still be permitted, so one can still brush up and down, left and right. Here you can see our first prototype in full action. From our initial user input, we needed a more fluid, faster reacting design. We upgraded the microcontroller from an Arduino Nano to a Teensy LC, which managed to both decrease the cost and size while improving the processor speed. We also eliminated the use for a breadboard through the design of a custom printed circuit board, or PCB. We 3D printed a press-fit case to improve water resistance of the toothbrush and increase the ability for a user to grip it. We also added the option for a removable toothbrush head for potential versatility in additional electrically powered or stationary attachments. And here you can see our latest, most improved design, boasting smoother compensating motion and versatile attachments. This overall newer and more practical design costs an estimated $120. Although no comparable device exists right now for specifically brushing the teeth, we can compare this device to normal toothbrushes, particularly electric ones, as those are recommended for Parkinson's, as well as innovations towards eating utensils. Our proposed design costs fall within the ballpark of medium to higher-end electric toothbrushes, but with the added premium of stabilization, grip, and weight. The weight of this toothbrush is 260 grams and is also comparable to a weighted eating utensil at 200 grams. The diameter of this grip is 2 inches, and again, comparable to large-barreled detachable grips typically added to handheld daily use objects like pens, razors, and spoons. It is important to note that these laddered compared objects do not house electronics. However, the end goal of this project is still to match closer to the weight and width of the grips of these attachment handles. We are determined to drive down these costs while still maintaining performance of the system, to not only address the dental hygiene problems of populations lacking fine motor control, but to restore their confidence in living independently. We aim to do this by directly addressing the size and bulk of our design by sourcing smaller motors and buying in bulk. Through sourcing smaller motors, we can obtain our sampling offset angles closer from the toothbrush's center line, and in turn, make the device more accurate in its response and improve the handle and feel by the user. That input will of course come from additional testing from more than just a few people with Parkinson's, to determine optimal weight, grip width, balance, and other parameters that were not addressed in the second version. Our plan looking forward is to open source all the code, the fully CADed casing, and PCB designs. We might also consider adding an industrial design student to our team who can remodel the design and materials before the next version, as well as incorporating a more ergonomic grip. Software-wise, we hope to implement machine learning in our code by adding a Kalman filter to our PID controller in hopes of creating even more smooth responses. Overall, our hopes in doing this is to inspire people from across the web to see or build this toothbrush on their own and either build upon this idea or become inspired to develop other tools with the potential of making everyday life easier for everyone.